Hello grade 9s, this is Mr. Miller and welcome to lesson 8.1 on solving equations in the form ax equals b, x over a equals b, and a over x equals b. So the first thing we're going to do is solve each equation using a number line and check the solution. So let's just zoom in on this problem 1a. So here we have 3x equals 4. And so we can draw a number line and put some numbers on it and represent 3x. So here we've got three little arrows going all the way to 3/4. So it's pretty easy to see that one of these x's would be 1/4. So that's the solution. Now we're also supposed to do a check. So you take the original left-hand side of the equation, which is 3x, and the original right-hand side of the equation, which is 3/4, and you have to substitute x equals 1/4 into and replace x. So we do that, and 3 times 1/4 is 3/4. So since x equals 1/4 satisfies the equation, and when I say satisfies the equation, it makes the left-hand side equal to the right-hand side, that means the solution is valid. Now let's take a look at the next one. We have c over 4 equals -2/3. So again, you draw a number line, and you put some numbers on it, and you can see that 1/4 c goes to -2/3. So, well, if 1/4 c goes to -2/3 and we want the full 1c, we need to have 1, 2, 3 more of these. So now we've got 4/4 c, which is 1 full c. You can see that that is -8/3, or you could also write it as -2 2/3. So that's the solution. As for the check, we start with the original left-hand side and right-hand side, and we replace the c value with -8/3 or -2 2/3, whichever you prefer. Of course, improper fractions are generally easier to work with. And when you divide fractions, you multiply by the reciprocal. 4 as a fraction is 4 over 1. So you multiply by 1 over 4, and as a result you get -2/3, and maybe it would help just to see how this happens. You can divide out a factor of 4 here and there, and it would be 2 times 1 is -2/3, and 3 times 1 would give you 3. Or you can do top times top, bottom times bottom, and reduce afterwards, but regardless. So what you can see here is that c equals -8/3 does satisfy this equation. When you plug in c equals -8/3 into the equation, you get the left-hand side equal to the right-hand side, so you know the solution is valid. So now we're moving on to number 2, where it says to solve each equation algebraically. And so there's a big hint here. Since there is only one variable located in each of these equations in one place, you can use the method of inverses. So we'll do that as we look at each of these questions. Now let's zoom in on 2a. Alright, so here we have 3x equals 2/5. So we can divide both sides by 3. Notice that we're doing 3 times x, so dividing both sides by 3 is how you're going to solve and get a single x. And you get x equals, 2/5, you're going to multiply by 1/3, because when you're dividing fractions, again 3 is 3 over 1, you multiply by 1 over 3, and that gives you, as a result, 2 times 1 is 2, and 5 times 3 is 15. 2/15 is the solution. Now let's take a look at the part B. And here you can see what I've taken as the first step. Since you're dividing m by 5, multiplying both sides by 5, And now you get m equals negative 10 thirds. So because 5 times negative 2 gives you negative 10, and 1 times 3 gives you 3. Negative 10 thirds can also be written as a mixed fraction as negative 3 and 1/3. Now there is another approach that you could take to get this solution. So one thing to know is that when you have an equation with fractions in it, you can multiply both sides of the equation by the least common denominator in order to eliminate the fractions. So here we have two denominators. They are 5 and 3, and the least common multiple between them would be 15. So you could multiply both sides of the equation by 15 first. What you would end up with as a result is 3m on the left and negative 10 on the right. 15m divided by 5 would be 3m, right? 15 times negative 2 is negative 30 divided by 3 is negative 10. So you still have to divide both sides by 3 at that point to get m equals negative 10 thirds or negative 3 and 1/3. Well, you can see we get the same solution either way. Okay, so now on to part C. We have negative 4.5 times x equals 1.35. So we can divide by negative 4.5 on both sides of the equation to solve. That gives us x equals negative 0.3. Again, the 1.35 divided by negative 4.5 will give you negative 0.3. Now there is another way that you can solve this. It's a little bit more involved, but if you have an equation, generally speaking, with decimals and you don't want to have decimals, you can multiply both sides of the equation by a power of 10 and it will eliminate the decimals. So multiplying negative 4.5 by 10 would give you negative 45. If you wanted to get rid of the decimals on the right hand side, you'd have to multiply by 100 to get 135. So we're going to have to maintain the balance here, maintain the equation, multiply both sides of the equation by 100. 100 times negative 4.5 will give you negative 450. Then you have the times x afterwards. And 100 times 1.35 will give you 135. So now we have an equation that no longer has any decimals. If you're trying to get rid of the decimals, that's a good way to do it. Still have to divide both sides by negative 450 in order to solve for x to get x equal to negative 3/10. But you can see that as we have it here, x equals 135 over negative 450 is actually a fractional answer. So if you're looking to switch over to fractional answers, then that would be a good way to do it. You just have to reduce this down to lowest terms. Of course, you can still write it as negative 0.3. That's still an exact answer, so there's nothing wrong with that. Either way, it gives you the same solution. So now just comparing that with what we did in part B, notice that in part B, we had a form of an equation which maybe we don't want to work with. If you don't want to work with fractions, you can multiply both sides of the equation by the least common denominator, which is the least common multiple of these two denominators. Multiplying both sides by 15 gave us 3m equals negative 10, and there were no more fractions in the equation. In a similar kind of way, if we wanted to change the form of the equation, if we didn't want to have any decimals in it, we multiplied by a power of 10. So now on to a little bit of a different example here. In part D, we have an equation where the variable is in the denominator. And that might seem strange, but it's actually not that difficult because this really just looks like a proportion. You have a ratio equal to another ratio. And one way to solve that is just to cross multiply. So doing m times 1 and negative 5 times 3. So there it is. Of course, m times 1 is just m, and negative 5 times 3, that gives you negative 15. So there's your solution. So now we're on to some problem solving. And it says to use an equation to solve each problem. Let's have a close look at what we can do for part A. Alright, so it says that Carol gave a 15% deposit on a diamond bracelet. The deposit was $73.50, and the question is, what is the cost of the bracelet? So besides the specific solution to this problem, I also want to talk about general instructions for solving problems with equations. So the first step should be to write a statement to define the variable. So in this case, it would be appropriate to say, let C represent the cost of the bracelet. The second thing you should do is to write an equation. So in this case, 0.15C equals 73.5 because 15% of the cost of the bracelet is 0.15C, and that is equal to the deposit, which is 73.50. The next thing you should do is to solve the equation. So that may have a few steps. The first step here is to divide both sides by 0.15, and as a result you'll get C equals 490. So now that you solve the equation, you should answer the question or questions, depending on the particular problem, with a full sentence. So saying that the cost of the bracelet is $490. And it's a good idea at this point, before you answer the final or give your final response, to make sure that you go back and you reread the question. Because sometimes they'll say what is the cost of the bracelet, or sometimes they'll add a little bit extra, like including tax, and you may need to do a further calculation. So it's a good idea to keep that in mind. Alright, so let's take a look at a few other problems. Here it says that Eric earned 2/5 of the profits of the canteen on the weekend. His earnings were $620. And the question is, what is the total profit earned in the canteen? So first, let's say let P equal the total profit earned in the canteen. And we know that 2/5 of the profit is equal to $620. So there's your equation. Now to solve the equation, we divide both sides by 2/5. And you get P equals, now to do this, to divide 620 by 2/5, you take 620 and write it as a fraction, 620 over 1, and you multiply by the reciprocal of the 2/5, which is 5 over 2, and that will give you P equals 1550. Now we write a full sentence answer. The total profit earned in the canteen was $1,550. We've just got a couple more to go. Next one. It says the density of an object is determined by the formula D equals m over v, where m is the mass in grams and v is the volume in liters. What volume does the object occupy if an 8.58 gram object has a density of 3.3 grams per liter? So first of all, note that all the variables were predefined in this question, so we don't have to say let D equals, let M equals, let V equals, anything like that. It's already set up for us. So all we have to do is replace the D with the density, 3.3 grams per liter. Replace the M with the mass, 8.58 grams. The V is the volume, which is unknown. Notice that I put the 3.3 over 1 so that I've got a fraction equal to a fraction, and I can do cross multiplying to solve, just like we had done on the previous page. So that's what I'm doing next. 3.3 times V and 1 times 8.58. Dividing both sides by 3.3 will give me a result V equals 2.6. And now that I have solved the equation, I can write my full sentence answer. The volume of the object is 2.6 liters. And finally, it says here Jamal received a 20% discount when he purchased his computer. He paid $920. What was the regular price of the computer? So first of all, letting R represent the regular price of the computer. Now there's a 20% discount, so starting with the regular price and subtracting 20% of the regular price will give you the discounted price of $920. But note that at this point we've got R appearing in two terms. So the first step is going to have to be for us to simplify this left-hand side to just one term. So if you've got 1R, take away 0.2R, that leaves you with 0.8R, which is equal to 920. So now we can divide both sides by 0.8. and that will give you R equals 1150. Therefore, the regular price was $1,150. So that concludes this lesson. If you have any questions, feel free to ask in class, and I encourage it, of course. And hope you guys have a wonderful day. See you later.